Okay, when we talk about angles, I think we probably have a pretty good idea what an angle looks like. We've seen a lot of different angles from time to time throughout the years, probably. We're going to talk a lot about angles as we go throughout the year in different situations. And so this is one of your basic shapes of geometry. Kind of like we have line, ray, segment, all of those. Angle is a shape in geometry that is used quite a bit. And so we have ways to identify that angle, ways to name that angle. And then eventually we'll talk about like what type of angle do we have. Is it an acute angle? Is it an obtuse angle? That kind of thing. All right, so what makes up an angle? Well, an angle is made up of two rays that share the same endpoint. So in this case, I might put like a B right here. B would be the common endpoint. And my two sides would be BA, ray BA, and ray BC. So that goes back to naming our different figures, in this case naming the ray. So ray BA and ray BC. When we name this angle, there's lots of different ways that we can name it. Okay, we could use 3 letters to name it. We always put an angle symbol in front, so we're going to say angle, and one way I could name it would be angle ABC. We're just going to go around the ABC. I could also reverse it, and I could go angle CBA. I could put a 1 in here. That's not the degree of the angle. That's just a letter, or in this case, a number that is used to name that angle. So I could call it angle 1. And it could be any number, okay? The reason we do it that way, later in the year, we'll have a picture that'll have like 10 angles in it. And so we'll label those angles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And it'll say, find the measure of angle 7, maybe. And so we'll label it with numbers rather than letters. Easier way to name it. Okay, and then the fourth way we can name it, as long as there's only one angle at B, is I could call this one angle B. Okay. All of those mean the same thing. Okay, so which one's more right than the other? None of them. They're all, any of those would be possible ways to name that angle. I could not do that here, okay? If we notice this one here, we have this angle here, that meets at F, and then we have this angle here, that meets at F. So I can't say angle F, because if I say angle F, which angle am I talking about? I could be talking about this little angle right here, I could be talking about this little angle right here, or I could even be talking about this big one right here. So there's really 3 different angle F's I could be referring to. So that's why we can't say angle F. If we look at the picture up above, there's only one angle at B. This is the only angle at angle B, so it's pretty easy to identify what angle we're talking about. Not so much on this one down here. So that's what this is talking about. When a point is the vertex of more than one angle, you cannot name it using that letter, okay? So when I name the different angles in this picture, okay, if I name the top one, we could either call it GFE or EFG, okay? Either way would be fine. Some people will say, do we have to go alphabetically? Not necessarily, okay? A lot of times we probably would, but if you say EFG and I say GFE, we're talking about the same angle. So that would be the first one. Okay, the second one would be this bottom angle right here, GFH or HFG. And then the third one, if I take out this ray in the middle here, now we're talking about this bigger angle right here. And so we're talking about angle EFH. So there's three different angles. They would all have three different angle measures. And they're all named a little different. So when you look at an angle, you really have to follow the path of the letters that we have. If I give you a problem that says find the measure of angle EFH, I'm going to go here, I'm going to go EFH, and I can see the path that those letters would take. So I just follow that path. Okay, try naming the three angles in the picture with the lighthouse. M is where the lighthouse is located. See if you could name those three real quick. Just do it on your paper and then I'll call it on you. All right, Brody, what do you think one of them would be?
JKL.
Okay. Okay, can we go JKL?
No.
Okay, there's one point that has to be used every time. Notice on this one here, what did all three of these have in common?
Geez.
Yeah.
Like J or KML.
KML, there you go, KML. Okay. We got to make sure we go to M. Every time M's got to be in the middle because M's the vertex. Braylon? What would be another one?
JML.
JML? Okay. Easton?
JMK.
JK. Okay. There we go. Those would be our three. Okay. And these three can be flip-flopped. Okay. The one thing that cannot be changed is M's got to be in the middle. Okay. So that's like the first one that was mentioned. We don't want to say JKL. We always got to go to the vertex. The vertex is where the angles meet at. It's the common point that those rays share. So that's the one we got to be careful of. All right, here's another problem going through naming. Okay, which one does not belong? Okay, and so basically which one does not fit with the others? So we have angle 1, which is this angle here. Okay, can I also call angle 1 BAC? Yeah, okay. We go BAC. Can I call it BCA? No. Why? A is not in the middle. Okay. Here A is in the middle. Here C is in the middle. Okay. Angle C would be this angle right here. That would be angle 2. So this is the one that doesn't fit because the last one has A in the middle also. So this is the one that does not belong because C is in the middle. And the angle that we are referring to has to be angle A. That one there. Okay, types of angles, names for different angles. I think you guys have probably been exposed. Have you guys seen all of these before? Acute, obtuse, right? Yeah. What about straight? Ever seen a straight angle? Okay. That would probably be the one that I wasn't really sure about if you've seen before. Okay, an acute angle is an angle less than 90. So that means the angle measure has to be between 0 and 90. As of right now, in geometry, we're never going to have a negative angle measure. Okay, when you get to trig, there are some times where you might have a negative angle, but we're not going to worry about that in geometry. Okay. So 0 is the lowest it could ever be. 90 is the highest. And it's not including 90. It has to be less than 90. So somewhere between 0 and 90. What that's going to look like would be something like that. Okay? A right angle is going to be straight up and down. This is going to be a little bit less than that. Okay, an obtuse angle is any angle bigger than 90, but less than 180. somewhere between 90 and 180. Hey, when I think of an obtuse angle, I kind of think of like taking a recliner and laying it back. When that backrest sits back, then it kind of makes a bigger angle. Okay, and you sit your feet back, then that's making an obtuse angle. A right angle is always going to equal 90 degrees, exactly 90. And there's a symbol that we use when we have a 90 degree angle. Anybody remember what that symbol is? Or anybody know that symbol?
The square.
The little square, yeah.
Square.
Yep, a little square in the corner, okay? So we're going to see this symbol a lot when we talk about angles. Anytime we see this little square in the corner, that means we have a 90, okay? If I draw a picture up here, and I ask you, is this 90?
Yes.
No.
No.
Don't know, right? Could it be?
No.
Maybe, right? It looks like it could be, but we don't know unless it has a square in the corner. As soon as I put a square in the corner, now we can say without a doubt it's definitely 90 degrees, okay? But there's another time where pictures can be a little deceiving in geometry. We might look at something and we might say, sure, it looks like it's 90, but do we know that for sure?
No.
Okay, and sometimes maybe yes, sometimes maybe no. Okay, a straight angle. Remember, a straight angle is similar to a straight line. And that's exactly what it is. So it's two opposite rays going opposite directions. So maybe this is A, and this is B, and this is C. And so what I would say here is, first of all, it has to equal 180 degrees. And I'm going to say that AB, ray AB, and ray AC are opposite rays. Two rays that are going in opposite directions. And we actually talked about that earlier in the chapter, and so that's why I'm bringing that back into play here. We talked about what a ray was, and then we talked about opposite rays. Opposite rays form a line, and it makes a straight line. So a straight angle is a straight line. Okay, protractors. We usually don't do a whole lot of work with protractors. It's not something we spend a lot of time with. This would be a bigger protractor. We used to do a little bit more with protractors and make everybody get like a little protractor they had, but then we weren't using them that much, so we hated to have everybody do some with that. But when I measure a angle, this would be the tool that I would use, okay? And so that's what we see up here, is we see an example of a protractor measuring all these different angles. There's two different scales on this protractor, okay? And so if I looked at this angle right here, KHJ, this one right here, what type of angle would that be?
45.
Okay, close.
80.
Okay, first of all, is it acute or obtuse? Is it bigger than 90 or less than 90?
Acute.
It's acute, right? It's less than 90.
Yeah.
And so we're going to go off this bottom line right here. This is kind of the center. That's what this little mark right here is. This is kind of the center where the picture would be, or where the center of the angle would be. And we're going to line it up with the bottom ray. And as I look at this, this is an acute angle right here. So we're going to look at the smaller number, between 50 and 60, and it tells us that would be right at 55 degrees, okay? If it was an obtuse angle, we would be talking about the angle that's between 120 and 130. So if I did GHK, GHK is going from GH all the way over to K, and so that would be the angle that is 125. So you have to decide, is the angle acute or obtuse? Are we using the bigger number or are we using the smaller number? Austin?
So, like, we go off the bottom of the numbers, like there's
two sets of numbers on the thing, we go off the bottom one?
Depends on if you have an acute angle or an obtuse angle. Okay?
No, I'm saying like, it says, so for line K, it says like, what, 50 and 60, but on the top it says 120.
Right. Okay, so we're going to do some examples here in just a second, and I think it'll make more sense. Okay, so here's what we do. GHK. I'm going to highlight GHK. Let's do it in a different color. We're going to go GH to K. If I look at that angle, is that angle less than 90 or bigger than 90?
Bigger than 90.
Bigger than 90, okay? So I have two choices here. I can either use the number that's between 50 and 60, but that's small, right? I want the one that is bigger, because what we're saying here is that this is an obtuse angle. It's falling backwards. And so we want to use the bigger of the two numbers. So between 120 and 130, if I counted my markings there, we would say that this is 125 degrees. And then when we classify it, we would say that it's obtuse. Okay, does that make sense? Why we would use the bigger one? Okay.
Do you always want to use the bigger one no matter what?
Not always. Nope. Just if it's obtuse. Yep, just if it's bigger than 90. Okay, so if I go JHL, okay, JHL, we're going to go from here up. So this is 0 right here, essentially, right? 0 all the way over to where this is at. How many degrees? 90, okay? So this is a 90-degree angle, and we would classify that as a right triangle.
I like the shirt today, by the way, Mr.
Thanks. Okay, LHK. Now here's where it gets a little bit trickier. Okay, because we're not going off the bottom, so I'm not just working my way around. Okay, in this case, it really wouldn't matter which number I used necessarily. Okay, we're trying to figure out how many degrees are between these two rays, basically. So we're looking for this angle right here. How far is it moving? How many degrees is it moving? So this goes from 90 down to 55. Okay, so if I went from 90 to 55 or 55 to 90, whichever way you want to go, how far are we moving?
45.
Close.
35.
35. Okay. So what I would do here is I would do 90 minus 55, which is 35 degrees. Okay. I also could have used the big numbers here. This is 90. This is 125. So 90 over to 125 would also be 35. Okay. So you could use the big one. You could use the small one. In this case, my angle would be acute because my final angle is less than 90 degrees. Okay, questions on finding the degrees? So if we ever have to find the degree of something, we would just use the protractor that we have here. One of the reasons why we don't really use a whole lot of protractors is because we do our assignment on big ideas, and trying to slap the protractor up on top of a computer screen isn't ideal. And so if they ask you to measure one, the protractor would be right there on the screen for you to measure. Okay, on this one here, two angles that have the same measure. What word do you think we're going to use here?
Equal.
Equal would be good, okay? Congruent, okay? The other day when we talked about segments that were congruent, I told you that word was something we're going to see a lot. We can also do it with angles, okay? So I could say these two angles are congruent. I could say these two segments are congruent. It simply just means they have the same measure, the same length, the same degrees, whatever it might be. Remember the symbol, once again, for congruent is that tilde sign with the equal sign underneath it. Okay, what does that look like? Well, I could draw a picture up here. Okay, and we could say, how do we know that these two are congruent? Well, I could give you the actual angle measure. If I tell you that this is 30 degrees and this one's 30 degrees, then we know they're congruent, right? We can also put a symbol in there. When we did the segments the other day, remember we put the little marking on it, the little tick mark on it, to say this and this have the same marking on it, so that means they are congruent. For an angle, it will be a curved marking. If these two angles have that same curved marking in here, that means these two angles are congruent. Okay? So this angle and this angle have the same measure. They are congruent, however you want to say it. Okay? All of those mean the same thing. Okay? And here is what I would say. The measure of angle B is equal to the measure of angle S. That little m in front of the angle means measure. We don't actually know the measure of it. I'm not asking you to find the measure in this particular problem. We're just comparing the two. Another way that I could say this is that angle B is congruent to angle S. And that means that they have the same measure. They are congruent, therefore they have the same measure. Okay? So those are all different things that we can say about that picture without even knowing the actual angle measure, right? We don't even know what the angle measure of it is, but we can make some statements about it. Okay, as we look at this quilt design down here, we got a picture with all kinds of different designs going on in it. And we want to know, first of all, identify the congruent angles labeled in the quilt design. Okay, so we're looking for two angles that have the same marking in them. Okay, and there's a couple of different ones here. One of them would be angle G. Notice it has one marking, and angle B has a marking. So angle G and angle B would be congruent. And you just make that statement. Because of the marking. Once again, I don't know what the measure of that angle is. Don't really care what the measure of that angle is at this point. We know they're congruent. We know they're the same measure. If I have more than one that are marked, then what they do is they put an additional curved marking in. So anything that has the exact same marking is going to be congruent. So in this case, angle F and angle D have the same marking. So angle F is congruent to angle D. They are congruent. Okay. Part B. If I tell you that ADC is 140 degrees, so now I'm telling you what the degree is, okay? If I tell you that this angle here is 140 degrees, what other angle would be 140 degrees? Braylon? Angle F, okay? Which another way of naming it is EFG. So angle F or angle EFG or GFE, all of those mean the same thing. So I would say measure of angle EFG equals 140 degrees. Okay? And there, once again, you see that little m. M means measure. How many degrees is what we're talking about there. Just another little symbol we got to become familiar with. Okay, we already talked about what this statement means. Matching arcs means they have the same number of markings. If I had like 4 different pairs of angles that were congruent in a picture, I could put 4 curved marks on both pictures, on both angles, and say that those are congruent. Okay, probably wouldn't do that very often where I have that many markings on there, but you might see like the 1 and 2, maybe 3 in the same picture. You're just using multiple arcs. Okay, the other day we talked about the segment addition postulate. This postulate is very, very similar in the way it acts and looks, okay? Except on a segment addition postulate, guess what? I know the name is kind of confusing. We use segments, right? So on an angle addition postulate, what do you think we're going to use? We're going to use angles, right? So we're going to use angles, and we're talking about adding two angles together to make a big angle. So if I gave you a big angle, and I tell you that the measure of RST is, let's say, 80 degrees. Okay, I'm going to put that into this statement right here. RST is 80 degrees. I'm going to label this picture. And that's that angle right there. Okay, you could put an 80 on the inside, but I'm not going to do that quite yet. Okay. Now, if I were to draw another ray down the middle of that angle, not necessarily that splits it in half, okay, so not right down the middle of it, but if I were to draw one that looks like this, and I'm going to call this one RSP. P would be right here, okay? RSP plus PST would equal this whole thing, okay? So what I could do in here is maybe I tell you that this one here is 30 degrees. What would measure of PST have to be? 50, right? Because these two angles together have to add up to be the big one, okay? And I just made that combination up, okay? I could do two things that add up to be 80. Any two combinations that add up to be 80, 45 and 35, or whatever it might be, okay? They just have to add up to be 80. We know the big one, the two small ones have to add up to be the big one. If I gave you the same picture, and I draw this ray in there, okay? Right now, do I know the measure of these two angles? No. Nope. Okay? But if I did this, assuming the measure of RST is still 80, okay? We'll still go off of this statement here. What would be the measure of these two angles? 40, just 80 divided by 2, right? Because this marking tells me these two angles have to be the same. So if I know one, I know the other, and they have to be the same. So that is what we call an angle bisector, okay? A bisector takes something and splits it in half. In this case, it's an angle. Not too long ago, we had a segment bisector, where we had something that was in the middle of a segment. So there's another word that we're going to see in a lot of different ways. Bisector, okay? It just depends on what we're bisecting. Are we bisecting a segment, an angle? What's being bisected? And in this case, usually it'll be a ray. The way that I would write this, I'm going to call this SM. Okay, so I'm going to say that ray SM is the angle bisector of angle RST. Okay, so that's what the statement would look like. We've got a ray that is splitting that angle in half. Okay, we have a couple of different variations of some things that are going on. So we got to read these problems carefully and kind of determine what's going on, and then we're going to take that information, we're going to use it to answer the question that's trying to be asked. So, angle LKN. Angle LKN is 145 degrees. Okay? That's the big one. So that's our big angle. What would be true about these two angles? Do they have to be congruent? No, not necessarily. Okay? Could they? Maybe. Based off the way the picture looks, probably not. But once again, we don't always want to judge based off the way the picture looks. Okay? So we don't know if they're equal, but what do I definitely know about these two?
That one's, it's like.
The big one's 145, right? And
the other one is,
so these two are going to do what? What do you think? They're going to add up to equal 145, right? The two smaller ones, the two angles on the inside of the big one, are going to have to add up to equal that big one. Okay? So that's what we know here. And so if I were to write this out, here's what it's going to look like. And I'm going to write it out with letters first. I'm going to say angle LKM plus angle NKM equals angle LKN. We already know the measure of that one, 145 degrees. So we're going to go ahead and put that in. Okay, I don't know the actual measure of these two, but I have an expression that represents it. Okay, so here's where your algebra skills are going to come into play. LKM is this angle right here. Okay, it's pointing down here to this angle. So that would be 2x plus 10. So we're going to put 2x plus 10 in place of LKM. MKN, or NMK, or NKM, however you want to write it, is 4x minus 3. So plus 4x minus 3. If you want to put them in parentheses, you can. You don't necessarily have to because they're in parentheses here. The only reason they're in parentheses there is just to show you that it's a degree. It's an angle. Okay, what we're going to do now is we're going to solve this equation. So if we solve this equation out, what would be our first step?
Combine like terms.
Combine like terms. Because they're on the same side of the equal sign, right? 2x and 4x would add up to be 6x. So we're going to combine like terms. 10 and 3 are on the same side, but you got to be careful here because it's a minus 3. So this would be 10 minus 3. So be careful as you combine it, okay? We're not doing opposites there. We're not moving it to another side. It's on the same side as one another. So we're just taking 10 minus 3, which is 7. And now it's a two-step equation. So now we're going to get x by itself. We're going to subtract 7. And we're going to divide by 6. Okay, what's that give me? 23. Okay, we talked about this last week too. Be careful with what's being asked, right? If I said, what is x? I'm done. That's my answer. X equals 23. But this is saying, what is the measure of LKM and MKN? So, measure of angle LKM is 2x plus 10. So I'm going to do 2 times 23 plus 10. Okay, what's 2 times 23?
46.
Okay, and then add 10 to it. 56. So this would be 56 degrees. Okay, then I'm going to do angle MKN. So we're going to do 4 times 23 minus 3. We're plugging it into this expression right here. 4 times 23.
93.
Okay, 93 minus 3. Try again. 4 times 23. 92. That sounds better. Okay. 92 minus 3? 89. Hey. What do you think I could do to check my answer here? See if I'm right.
Putting it back in the equation.
Okay, put it back in the equation. Or what did we say just a second ago? These two angles better add up to be 145, right? Does 56 plus 89 add up to be 145? There you go. Okay, that's a really quick check. Okay, and all that does is that tells me, hey, I did something right. Okay, if it doesn't add up to be 145, then there's a big red flag there going, what in the heck did I do wrong? So I encourage you to check your answer when you have the opportunity to check your answer. Hey, this one is not quite as lengthy as the one we just did. Right away, I see these two markings. Okay, so if this is 24 right here, what do you think this guy down here is going to be? 24. Okay. So those markings are pretty nice when we see them. I immediately know both of those angles. Okay, but we are looking for the measure of angle PQR. Okay, PQR is this big angle right here. This half is 24, this half is 24, so what are we going to do with those two? Add them together. 24 plus 24. So that would be 48 degrees. Okay, that one a little bit quicker. Okay, right here is when we have to know what each of these terminologies or vocab words mean. When I see a straight angle, what's straight angle tell me? It's 180. Straight line, right? So this angle right here, KLM, is 180 degrees. I'm not going to write out the whole equation here. I'm just going to go ahead and put 180 down because we know it's a straight angle. That's what the definition of a straight angle is, 180 degrees. This side plus this side add together to equal the big one, right? And the big one is 180. So this is kind of similar to the one we did just a few minutes ago. 10x minus 5 plus 4x plus 3 equals 180. Add 2 to both sides. And divide by 14. Okay, once we are there, then we're looking to find these two angles here. So measure of angle KLN is 10 times 13 minus 5. 10 times 13? 130. 130 minus 5? 125. Okay, the measure of angle NLM would be 4 times 13 plus 3. Okay, and if I wanted to check myself again, kind of like we did up above, these two together have to add up to be 180. Okay, and they should. And that's how you can always check yourself. Okay, I'll make